Welcome to the Stormsurf video surf forecast for the week starting Sunday, May 24th. Looking at significant wave heights for the South Pacific Ocean, we see a broad gale trying to develop southeast of New Zealand, generating 31-foot seas aimed pretty well to the north. Otherwise, a pretty calm pattern is in effect. First up, we'll take a look at jet stream level winds. These winds help support the formation of storms, and when those storms do form, help direct their path. Currently, we have a nice trough developed here, southeast of New Zealand. This trough, that is winds pushing to the north, help create a clockwise circulation in lower levels of the atmosphere, sort of an eddy. Consider this actually like a river. This is an eddy, and that eddy helps create clockwise circulation both aloft and down at the surface. That is low pressure at the surface, and that is what generates waves relative to our forecast area. So, here we go. We have a trough here that is supporting the gale that is currently generating surf southeast of New Zealand, but then right off to the right of it, notice a ridge pushing south. That would prevent swell generation in this area. And then another trough here in the southeast Pacific, but winds are rather weak. Winds here are, they're even weak in this trough, 90 knots, even weaker over here. This is the best area to support gale development. Let's put this into motion, see what happens. In the coming days, even by Monday, the ridge pushes hard to the south. The trough over here doesn't have a whole lot of wind energy associated with it. Not a whole lot of swell production is expected to occur because of that. And then we're into Tuesday. A little bit of wind energy tries to get going in this trough over here, but not really much. This trough holds. We'll just roll this out. And then you see the whole ridging pattern. This ridge has been holding over the entire South Pacific for weeks now, starting to break up, or at least it appears that way. Another trough tries to get organized by Thursday here in about the Central Pacific and continues on, but notice there's a little bit of undercut here. It's almost kind of a cutoff sort of trough. And then we roll this out, and the general pattern, though, is towards less activity south and appears to be a slightly improving pattern. Still a split jet here, most of the energy running flat west to east on the 30 south latitude line, but there appears to be generally more support here. Nothing great though. So for now, at least from the upper level picture, this area off here seems to be the area of most interest. Next up, let's take a look at surface level pressure, surface level winds. Here is our low pressure. Looks to be about, says 960 millibars here. That's pretty deep, especially for this far south in the South Pacific. But really, it's about 968 in the main area that we're interested in here. 45-knot winds aimed almost due north. That's well up the Great Circle paths into Tahiti, Hawaii, and the U.S. West Coast. And then sort of this other fetch here, but it's all pushing straight south. Not so much of interest. Let's put this into motion. Roll this out. 45-knot winds. Here's a small area, 50-knot winds by Sunday evening. Again, very small area. And then it builds to 55-knot winds. And notice, aimed right to the north. This is good. Roll that out some more. It holds into about Monday night, 45-knot winds. Then the system starts rapidly declining. Still a large area, 30, 35-knot winds, but it is the speed of the winds imparted on the ocean surface that generates period, and really period is more important than size, if anything. So 55-knot winds, that's good for 17, maybe 18-second period. Anyway, roll that out, and that low continues to gurgle, only producing 35-knot winds. That's generally what we would consider about 13-second period swell. Probably not enough to even make it up into the U.S. West Coast. Certainly good for Tahiti, though, in that area. And then a secondary fetch develops on Thursday. Again, only 35-knot winds, and that actually builds into a pretty good size area, but again, just not enough wind speed to really make any solid long period swell. And again, it's that period that helps the swell radiate over extremely long distances. And we're talking the better part of over 5,000 nautical miles to make it to the U.S. West Coast from here. So you need more than a 13-second period. Anyway, continued fetch. basically the whole way through the week, and we're into Sunday night a week from now, and finally that system peters out. So and this is the only real system of interest. We have ice down here. Whatever this is over ice, only good for making penguins freeze. Anyway, so let's go take a look and see what effect these winds have on the ocean surface. All right, significant wave heights for the South Pacific Ocean. We're actually going back in time. We're going back almost a week ago to Friday night, May 16th. And the point being here, there was a series of small systems that have pushed under New Zealand, courtesy high pressure over New Zealand, locking things down there. This is almost, one could say, a sign of El Nino, but we won't completely go that far and say that's what's driving this. But what that means is actually high pressure is counterclockwise in the southern hemisphere, rotates counterclockwise. What that does is sets up a continuous fetch. Any low pressure moving under Australia actually creates west winds in this area, and this is the source really of this fetch that created 34-foot seas. And watch this, where it is relative to Northern California here. That's on the 214, 215 degree track. Relative to Southern California, that's on about the same thing. It's hardly any different. 214 degree track. Relative to Hawaii, just barely in the swell window. That's 201 degrees there. Okay, but most of the energy was going this way, cutting across the Great Circle paths to Hawaii. But relative to California, aimed, you can actually see a little arrow right there, aimed almost right up the Great Circle paths. So the point being, there was this system that was a week ago. A second system developed in the exact same place, built stronger, 46-foot seas. And again, look at this. Here we go. That's the 215, 216 degree track, right up the Great Circle path, more or less to Northern California and Southern California. Not so well to Hawaii, but still in the swell window. There's the 201 degree shadow relative to New Zealand. So energy there as well. And of course Tahiti, which is hanging down here. And also relative to Costa Rica, yes, aimed well up towards Costa Rica. And let's go as far as Peru, yes, there as well. Tahiti, of course, Tahiti too. So that swell already in the water, working its way towards, for this case, the U.S. West Coast, middle of next week. Both those small swells. We're still back in time, and then things sort of calmed down for a bit, and now we're moving into current time. Here we go, right about there. This was Saturday morning. Little gale starting to develop, and we'll just see how this sort of gurgled down there. And then here we are, Sunday 18Z. This is that fetch that we saw, like 40 knot winds or so, blowing well to the north. And let's check out the Great Circle paths here. Now you see it's almost north of the Great Circle paths into Northern California. Again, this is that 215 angle, unshadowed by Tahiti. Same thing for Southern California. Relative to Hawaii, very well aimed up at towards Hawaii. There's the 201. That's, I think, about the 195. So let's say 197 or so. And, of course, Tahiti as well, right up the paths there. Anyway, this system is supposed to gurgle around, peak out. Not a giant system, not strong. What is that, like 42-foot seas, 41-foot seas? But again, now it moves into the Tahitian swell shadow here, and that's, I'm having a hard time seeing what that is, but let's say roughly about the 208 to 209 for Northern California. Southern California, about the same thing. Hawaii doesn't have to worry about Tahiti. That's right up about the 197 degree path there. So that one moves, pushes north, and then fades out. Remember, we saw 35 knot winds in this area pretty much all this week, and it produces, 20, 24, 26-foot seas. That's good for, 14 or 15 second period swell up into here, and certainly more size down into here, but nothing significant. And it tries to organize, there's a little patch of 30-foot seas projected. This is 162 hours out. Relative, we'll just do Southern California here, 195 degree track, past the Tahitian swell shadow. But again, a very tiny area, not a lot of size expected from that. And then, and then that's it for this week. So the main focus, storm southeast of New Zealand. We're going to play this one more time because we use this model here. We got the max significant wave heights. It searches the entire basin on the chart for the highest significant seas, pinpoints its coordinates, puts a little cross right there on it, then also looks 2 degrees either side, north, south, east, or west of where those significant seas are, finds the max winds in that area, figures out what those are, what its position is, and those winds' direction. So this is, again, the hindcast is what's happening right now. Everything past that is a fantasy of the model, but it gives you an indication of what's going on the internals of the storm. So let's just play this out. We see, what do we got? 35.7 foot seas, but really the area is so small. Here we go. Now we're doing better. 41 foot seas with winds 50 knots and winds blowing from 225 degrees in that location. And that probably is about the peak of it. Yeah, seas drop off from 40 feet, winds start dropping, and that's pretty much it. But still, 36-foot seas, that's all good for some swell if it happens. But we're only 60 hours out, so odds are something's going to happen. This has been on the charts for a while, but we just wanted to show you the actual details here. Now let's go take a quick look at the North Pacific. Here we go. North Pacific sea heights, significant wave heights. Basically, there's not a whole lot going on. We'll play this out. A little bit of a cutoff low forecast north of Hawaii on Wednesday. Seas don't even hit the 15-foot range. Probably not even good for wind swell. And then it just sort of fades out from there. We're into supposedly a little bit of tropical activity down here. And this is the biggest seas in the whole Pacific Basin next weekend, and they're only forecast at 12 foot per this model with winds 32 knots. So it builds a little bit, but not really anything. Certainly, tropical systems are not believable 180 hours out on the chart. So basically, North Pacific is shut down for now. Not even any wind swell really expected for California, and trade's light relative to Hawaii, so no wind swell. So all all the focus is looking at the southern hemisphere at this point in time. Now let's go look at some long-term indicators of what's going on. First up, the Southern Oscillation Index, difference in pressure between Darwin and Tahiti. The negative numbers for a long period of time, reasonably long, these are the daily numbers, suggest the active phase of the MJO. The active phase of the MJO in winter months helps support storm formation in the North Pacific, not so much so in the southern hemisphere during the northern hemisphere summer months. But if you see deep negative numbers like these are over a prolonged period of time, that also can suggest the presence of El Nino. We've been through a pretty good little run here. You'll actually notice, though, it's been negative almost for a month now. This is a month's worth of data, but a nice little burst here in the early to mid-May time frame. That mainly attributable to high pressure over Darwin, Australia, not so much low pressure over Tahiti. Anyway, that pattern is settling down now. The current daily number, minus 3.1. The 30-day running average, mainly due to all these negative numbers here, has dropped significantly to minus 16.80. That's a good sign. And we're back to the 90-day average, down now at minus 10. It was in the minus 8 range since October of last year into probably, the better part of March of this year. And then we had a pretty good run of positive numbers, and that washed out a lot of what was minus 8 here and got us up into like the minus 4 range. But now we're rebounding some. The point being, we want to see negative numbers. We want to see both the 30-day and the 90-day down. You really want to see the 90-day down around minus 15 to minus 20 if you're talking about a really solid El Nino in play, and we are not at that point in time yet. This tends to be a lagging indicator. The atmosphere responds. These numbers go negative once you're pretty well into the pattern. You can look for early signs in the daily numbers, but there's a lot of noise here. It jumps around a lot. Next, we look for the presence of westerly winds in the West Pacific. Here's Australia, Philippines up here, the date line here. You're looking for arrows blowing from the west, a couple of degrees either side of the equator. This is what we call the Kelvin wave generation area, from about 130 to about 170 west. That's 130 east to 170 west. A box right here. If you get westerly anomalies, and what that means is trades are basically backing off. Trades normally blow from the east at a pretty good clip here, but when they start relaxing, warm water that's typically in this area starts moving to the east. It falls to depth down to several hundred feet below the surface, and then starts working its way to the east. This is what's called a Kelvin wave. Right now, we have very weak westerly anomalies, but they are continuing the whole way across the dateline, and they build somewhat in the East Pacific. Here's Hawaii up here, dateline's back over here, and here's Mexico and Ecuador and the Galapagos Islands, but not a whole lot going on. Kind of a weak westerly pattern, nothing too strong. Now, a week from now, June 1st, those westerly anomalies are to build, still generally in the light to weak category, but any westerly anomalies help support warm water falling to depth and help support the formation of Kelvin waves. So every little bit helps. But we've had a good run. We've had westerly anomalies the entire year, and actually a good, solid, very strong event occurred in March, and then we just had another one a week or two ago, and now things are backing off a little bit. Anyway, weak westerly anomalies a week out, and then stronger westerly anomalies here in the East Pacific. That's actually down at 120, so that's basically due south of California. The point being, though, is strong westerly anomalies here do nothing to support Kelvin wave development. They do help push surface warm water to the east, which is another important component of El Nino, but the bigger component is these Kelvin waves and westerly winds in the far West Pacific. So right now we're kind of in a down phase, westerly anomalies, but not a whole lot is forecast for the next week, at least in terms of supporting Kelvin wave development. Next up, a little historical look. Reds, orange, purple are westerly anomalies, and this is the West Pacific here. This is the whole globe, the whole planet on one chart. But anyway, West Pacific is roughly here, East Pacific is roughly here. This was right in the heart of the Kelvin wave generation, early May, about a 10-day run of westerly anomalies, a westerly wind burst because they were strong, prolonged. It wasn't just anomalies, it was actual hard blowing westerly winds on the ocean surface. This has helped support development of a second Kelvin wave. We had as we said before earlier, really prolonged, strong, much stronger than this event back in the March time frame, and now yet another Kelvin wave. And then here we are. Here is westerly winds that occurred in the East Pacific. Here you go. That's south of California there. So that's that little patch we saw in the previous chart. Doesn't do anything for Kelvin wave development, but still, we'll take it just the same. And then they have a week of forecast, and again, it's suggesting kind of a neutral pattern with all your westerly anomalies in the East Pacific. What this means is that the active phase of the MJO is slowly working its way to the east. The converse side of that is the inactive phase of the MJO is likely developing in the West Pacific. So next we go look at outgoing long-wave radiation models. These, you can basically say the yellows are easterly winds, a lot of ocean, a lot of sun reflectivity off the ocean surface, high pressure, the inactive phase of the MJO. The blue is the active phase of the MJO, more precipitation, less reflectivity off the ocean surface. That's what these models are looking at, outgoing long-wave radiation or reflectivity. Anyway, the statistic model suggests pretty much a neutral to biased, slightly inactive phase for the coming 15 days, with the active phase building in the Indian Ocean. The dynamic model, even stronger, suggesting the inactive phase taking control. Now, what we've also seen is during these El Nino situations, just because you have the inactive phase in control doesn't mean that you don't have westerly anomalies blowing, just the odds for them are less, and when they do occur, generally, they're not very strong. So we got to get through a patch here before the next big westerly wind event takes effect. and that's what we need is westerly winds, more warm water transport to the east if we're going to get an El Nino, and that's what we're really looking for. And of course, in case you don't know, El Nino during winter months helps support storm formation in the North Pacific, ramps up the jet stream, and really you get a much higher likelihood of larger storms, stronger storms, longer duration, which means bigger surf, longer duration of bigger surf, and then, of course, the potential for rainfall down into California and across the southwestern tier states. It basically takes the jet stream, pushes it to the south. Okay, upper level flow here, oranges and yellows, the inactive phase, the MJO, areas not supportive of precipitation, greens and blues, the active phase. This runs about a week ahead of what happens really down at the surface, but here you can clearly see, here's South America, the active phase fading out, making its trek into the Atlantic Ocean. The inactive phase forecast, this is a 40-day model, by the way, so the inactive phase basically is going to take over the Pacific into about the 15th of June, let's say, and then a weak active phase builds behind that, makes its trek across the Pacific. So if there's going to be another westerly wind burst, it probably won't be until the mid-June-ish time frame at the earliest. All right, so next up, surface temperature, sea surface temperature anomalies. Differences is normal for this time of year. Notice the equator, warm water the whole way across the equator, markedly warm water. Here's the Galapagos building in this area. This is the result of the Kelvin wave from the westerly wind burst we saw earlier, working its way across under the equator, starting to hit land here, gurgle up to the surface, warming surface waters. The hallmark of El Nino is warm water in a pattern like that, right in that area. And we're seeing that now. This is looking pretty good, but it needs to get much warmer if it's going to be a super El Nino, or even if it's going to be a legitimate El Nino, and more warm water has to build in this area. So we're going to get into the subsurface profile here in a minute. But anyway, things are quite warm here, and if you have westerly winds blowing here, that's a good sign because there is warm water here to fall to depth to create another Kelvin wave. Of course, warm water pattern continues off of Hawaii, north of Hawaii. This is all just ripe for tropical development with the right upper level wind configuration. It's still kind of early in the season, so maybe a bit too much to ask just yet, but come the fall, if this pattern holds, we expect to see much tropical development. The other thing that there's been talk about with high pressure building in here, water temperatures cool down in this area. We're starting to see some signs of that. We did not see that last year. We did not see this much warming last year here either. Even though there was massive Kelvin waves, the atmosphere was not primed and not ready to support El Nino. It is possible that it is ready this year, but if it's not this year, maybe it will be next year. Let's compare the warm water pattern right now to what happened in 97. The good news is there is data from 1997, May 23rd, roughly the same time frame. Look at this pattern. Looks eerily similar. Also notice the cool water here. Eerily similar. Let's compare back and forth. Here we go. Warm water. Look at this. Even warmer south of the equator and the warm water here. Let's go back. Look at that. And then the warm water here. We'll just go back and forth a couple of times. Very, very similar pattern for this time of year. And then last year, we had warming too. We had a massive Kelvin wave. Its signature, not nearly as strong as this year's signature. So we're way ahead of where we were last year. Okay? Relative to the big super El Nino of 97, we are very, very comparable at this point in time. But we have much more to go. A month from now, June 1997, look where we were. Look at how much stronger it was compared to where we are today. Oops, there we go. And then in July, look where it went. This is July 97. The point being here, we need much more warm water working its way to the east if you're going to try to play ball and compete against the 97 El Nino. And one other way to look at this is actual moored buoys strung across the equator, giving us a good look. Here's actual winds. Notice there's still actually westerly winds. This was yesterday, the 23rd. Westerly winds, not just anomalies. And this is actual wind direction speeds and temperatures, but it's the anomalies that make the difference. Westerly anomalies still working their whole way over the date line, north of the equator, the whole way almost to the Galapagos, and water temperatures 1 degree above normal, surface warming 1.5, 2 degrees here, right on the equator. This is pretty well west of the Galapagos. This chart cuts off at about 90 or 95 west, so another 10, 15 degrees still off to the east to hit the Galapagos. But it is not what is going on at the surface. The surface is a symptom. It is what happens below the ocean. Meters down, 200, 300 meters down. Here's actual water temperatures, West Pacific here, East Pacific here. Here's the buoy anchors, sensors on the buoy anchors measuring water temperature gradients at depth. But it's not the actual temperatures, it is the anomalies that matter. And here we go, here is our Kelvin wave, and really the Kelvin wave cuts off like over here. And we're going to talk about this. There's actually 2 Kelvin waves going on here. This is the big one created in March. It takes the better part of 3 months to make its way across the Pacific. 5-degree anomalies, that's a significant anomaly, working its way into the Galapagos. This is what's causing the warming that we saw on the surface in the previous charts. And there's at least another, this goes out to 140 west. So there's another month at least of warm water in the hopper. Really, the warmest waters are just now starting to impact the Galapagos Islands. But here's the other part. You can see more warm water falling south. This is from westerly anomalies that occurred just 2 weeks ago, and a new lobe, a new Kelvin wave. It just looks like an extension of the existing Kelvin wave. That's exactly what you want to see, and you want to just see this go on for months and months. And the more you get westerly winds here, the more warm water falls in and just keeps feeding this pipe, and you just get a cycle going. And that's how you get, like you did it, like the chart we saw in the 97 El Nino, when in July you have just rapidly expanding warm water. That's caused by massive westerly wind bursts that just blow nonstop pretty much in this area. That's what we're looking to see whether this will just be it might be a Modoki El Nino. This same thing happened last year, though we saw on the water temperature charts, waters are definitely warmer over in the Galapagos than they were last year. Okay, so we are a step ahead, but the question is this pump going to keep going, pushing warm water to the west, or are the westerly winds going to die and all this warm water will sort of gurgle the surface, get caught by the trades, and just sort of dissipate, and we end up with Modoki El Nino like we did last year? Too early to tell. We will know, though, in the June-ish time frame, we think, because at that point in time, we'll be past this inactive phase of the MJO, we'll be past the spring unpredictability barrier, and we'll start seeing whether the pump and the west winds get going here over in the West Pacific. If that happens in the June-ish time frame, June to July, 3 months for the Kelvin wave to make its way across. So let's say June to July, August, September. The September-October time frame, that's when you want to see peak warm water starting to build over in this area at the surface. And yet another view of the Kelvin wave, and here's interesting because here is the previous Kelvin wave, still quite warm, 5-degree, 6-degree anomalies per this, and this gets the whole way over to about 80 west. So the Galapagos Islands are here. You're seeing it's just now really starting to fill in good there, and we've got a month's worth at least of warm water still to gurgle up. But now you see this development of the new Kelvin wave and temperatures starting to build here, so this is a good sign. The pump is doing pretty well. And finally, the forecast for sea surface temperatures in the Nino 3.4 region. That's the area that you use to monitor for the presence of El Nino. The forecast, of course, looks well off the chart, so it has settled down a bit from what it was earlier, suggesting water temperatures right now are 1.1 degrees above normal, working their way up to about 1.9 by July. This is 1.9 degrees above normal. And then 2.6 by October. We're going up to maybe 2.7, 2.75, which would be a very solid El Nino by the December time frame. This is the little bit concerning part here. It says 1.1 degree anomalies current. Look at this. Here's the temperatures for the 3.4 area. Currently, it suggests, this chart at least, suggests only about 0.8 degrees above normal, not 1.1 where it should be. So we're not sure whether this is an issue with this chart or reflects reality. All the other data we're seeing suggests there's definitely warm water building up in the far East Pacific. So we're not too worried at this point in time. But we know this chart is a bit off. This is an outlier. You look at the other models, and they're collectively further down. You look at all the other models, and you can draw different lines. There's dynamic models, statistic models, etc. But generally, if you just eyeball it, and these darker lines here are sort of the thought of where we'll be, and they suggest roughly 1.5 degrees above normal, which would be a mid-grade El Nino. The last El Nino we had in 2009, 2010 was about a 1.4, I believe. So, but the reality is, and here is the model we just looked at is one of these outliers up here at the top, the purple right here. So it's the highest of the bunch. So that's the most optimistic picture. But again, we got to really see what happens. A model's a model. You can't believe it this far out. What you go is by what's happening right now, and what we have is westerly winds. We have 1 Kelvin wave impacting. We have a second in flight. So those are all good signs. And of course, we have a series of small southern hemiswells working towards Hawaii, U.S. West Coast, Central America for this week. Another system developing southeast of New Zealand, high pressure over Australia, warm water building over the Galapagos. So all the signs are suggestive that El Nino is trying to get going, but nothing is for sure. But it's certainly better than La Nina, and it's certainly better than a high pressure locking everything down. So we're in a good place. So that's it for this week. We're going to do it again next week, same time, same channel. In the meantime, go get some surf. Have a good time. We'll see you next week. Thank you.